Okay. So in the last session, we have seen a couple of classes and corresponding methods, how they are working. And in today's session, we'll talk about TreeSet and different methods in there, and mainly about comparable and comparator. Okay. Okay, so actually we have seen a basic example about TreeSet. Let me again write that. So what I'm doing, I'm adding some numbers to it. 23. Okay, so first thing is so TreeSet. We have seen by default it will follow uh, some order. That is, if it is a number, then all the numbers it will take in ascending order, right? If it is a number. So if I print it, so the numbers are coming in ascending order to 12, 13, 23, 95. Whereas if I take strings, okay, instead of numbers, if I take strings, okay, so if I do it now, then now it will sort these strings based on the alphabetical order. right? So first C came and after that P, after that R, after that S. So why it is happening? Okay. Now, so we have seen for numbers and we have seen for strings. In the same way, suppose we have our employee class. Okay. So we have our employee class. It is just a poser class. It doesn't have anything. Okay. Now what I'll do, I'll add instead of strings, I'll add employee objects. Okay. Employee ID, name, mail ID, phone number. Employee ID, name, email ID, phone number, age. Okay. So in the first case, I have added numbers. It was sorting in ascending order. Second case, I have added numbers. It was sorting in alphabetical order. Third case, I am adding some user defined object. User defined object means this is this object we have created. I mean our custom object. Suppose string is predefined class object, right? This is our class. So user defined class object. Okay. So now when I run it, what will happen? It will throw an error. Let's see that. So what is happening? Class cast exception. Employee cannot cast to comparable. Okay. Employee cannot cast to comparable. I mean, this is the first time we are seeing. I mean, the so far we have discussed a couple of collection classes, list, array list, vector, stack, right? So we have directly added. Suppose if I take array list, okay. So what I'll do, okay. So I've directly added the same employee class instances. Now, if I just print list object, yeah, let me comment this. So we don't have any error, but the same object, when I try to add it to the tree set, so what it is saying, it is saying class cast exception. Okay, but whereas string is also object, when we add that, it did not show that error. Now the error that we are seeing is employee cannot cast to comparable, but where the comparable is coming. So what is happening here? TreeSet, what it is doing, every time when you are adding an object, every time when you are adding a new object, it will compare with the existing object, and based on the result, it will decide where to go. Where to go in a sense of, for example, let me take the same scenario for the numbers. Okay, let me 23. Let's take this. Let me comment this for now. So now if I print it, what it is happening, it is showing in the ascending order, right? To 12. And let me take this. So this is the result. So internally what is happening, every time when we are adding a new object, it will compare with the existing object, and whichever is lesser, it will keep that object before that existing object. Let's see this. For example, first we are adding 23. First we are adding 23. So basically first time we have created a empty tree set. It doesn't have any value. And first time after creating empty tree set, what we are doing, we are adding on number. So what it is doing, every time when we are adding a new object, we call compare method, or for now let's say compareTo. Okay, so since this is the first object, it will print as it is. For at this case, it will print as it is. It will take that as it is because this is the first element. Now second element. So when it comes to the second element, what will happen? Again, it will call the compareTo method. compareTo so 12 and 30, 23, because that is the existing value. 1 second, let me take my charger. Sorry. Okay. Okay, so what is happening here? First time it is added 23 because that is the first element, and the next time it is comparing with. So now we are adding 23. It will compare with. Now we are adding 12. It will compare with the existing element. So now between these two, so it will check three conditions basically. Every time uh, when we are adding an element, it will check three conditions. One is whether that element is less than the existing element or greater than the existing element or existing element. So for example, so 12, first thing is first is 12 greater than 23. Okay, now 12 less than 23, 12 equals 23. So every time when we are adding, it will check these three conditions. So for example, in this case, if it is true, I mean 12 is greater than 23, it will return positive number. Okay. Otherwise, it will return, if it is less than, it will return negative number. Otherwise, it will return 0. So in our case, which one is correct? In this case, so 12 is less than 23. So that means it will return positive number. Sorry, negative number. Okay. So whenever, I mean, that positive number, negative number can be anything. I mean, it can be 1, it can be 2, it can be 20, or it can be -1, -2, -20. So for JVM, it doesn't matter how much positive or negative number it is. It will just check whether it is positive or negative. Okay, to decide whether it has to go before that existing element or it has to go after the existing element. Okay, if it is a negative number, so simple thing here, if it is a negative number, then it will go before the existing element. If it is a positive number, then it will go after the existing number. So in our case 12 is less than 23, so that is negative number, so that means it will go before the existing number. So now the result here is 12 comma 23. Okay, so now up to this the result is 1223. Now the next case is again we are trying to add 34, so it is comparing 2. So what I told, every time when we are adding, it will compare with the existing element, that existing element also last element. So now what is our last element? 23. So now it will compare 23, 34 with 20. That is the existing element, latest element. Now again here also it will check three conditions, whether the existing element, the new element is greater than 23 and is that less than 23, is that equal to 23. So 34 is greater than 23, right? So we don't care like how much it is greater. I mean, what is the difference? We don't care, right? I mean, it doesn't require. it will just see like whether it is positive number or negative number. So in this case, because 34 is greater than 23, which is a positive number, so that means if a number is greater than some number, then the higher value will go after the lower value. So that means 34 will go after 23. So now since because 34 will go after 23, now our output here is 12, 23, 34. Okay, so when it comes here till here, our result is 12, 23, 34. Now again I am trying to add 93. Now, so what it will do, it will compare 93 and what is the latest last element, 34. So it will compare those two. Again same conditions, 93 greater than 34, 93 less than 34, or 93 equals to 34. Okay, so okay, so in this case what is correct, which condition will satisfy? 93 is greater than 34, so this condition is satisfying, so we'll get a positive number. So whenever we get a positive number, that means the higher value will go after the lower value. So 93 will go after 34, so that means 12, 23, 34, 93. Okay, when up to here, this is the result. Now 93. So far we did not see this case because in our all the cases, so it is straightforward that 12, 23, 34, 12, 23, 34, 93, it is coming in the same order. What it is doing, because so if you take this, we just compare with 94, 33. So since 34 is correct, so now here, because 34 is greater than 23, 23 is greater than 12, so we did not go back to see. So far we did not come any number which is less than 12. Okay, now so 2 is greater than 93, 2 is less than 93, is equals to 0. Okay, so in our case, in this case, so 2 is greater than 93, false, 2 is less than 93. This is true. So it is returning positive number. So that means 12, 23, 34 to 93. But here again, when it is trying to insert 2, again it is checking which one is higher, either 2 or 33. So since 2 is less than 34, then it will traverse to 2, 34, 93. Again 2 is less than 23. Again 2 is less than 12. Okay. So when you are adding an element, first it is checking with the latest element, and out of those two, the lower value will come first and the higher value will come after. Again with that lower value, it will again check with the next higher value, which is 34. So again 34, 23, sorry 34 2 is the lower value. So 2 will come before 34. Now again 2 will again check with 23. Again after the result 2 will come before 23. Again 2 will check with 12. So like that for every element internally it is comparing, and based on that it is placing that element, and finally we are getting the sorted result, right? So but if you see, if you observe here, so internally what is happening every time when you are calling an element internally, what is happening if it is a default. So because we did not do anything, right? We did not do anything. By default we are seeing result in some sorting order, which is ascending order, right? So that means internally it is calling some method where it is doing the comparison. Though, so that some method is compareTo method. But where this compareTo method is present, this compareTo method is present in the comparable interface. Okay. So whenever, if it is a default sorting order, okay. So for numbers or for strings, it will be a default sorting order, which is ascending order. So for numbers, based on the numbers, it'll take in ascending order. For strings, it will take in ascending order based on the alphabets. So that is a default sorting order that is happening through calling compareTo. That compareTo method is present in comparable interface. So that means those primitive, I mean those primitive values or wrapper classes. Like wrapper classes means integer, float, long, double. Those wrapper classes and the string, those internally implemented comparable interface. Otherwise, we cannot. If it is not called, not overriding, implementing this comparable interface, it cannot. We cannot call this compare to method, right? So what we are saying, every time when we are adding an object, it is calling the compare to method that is present in comparable interface. So that means these primitive classes and the string, they are implementing comparable interface. So when you are adding an object to a tree set, that means that class by default is implementing comparable interface. So that is why now we'll come to our example. So in other example for the array list, I've straight away added this employee object. It is not showing any error. Whereas to a tree set, I am trying to add the same employee objects instances. It is throwing class cast error. Cannot cast employee to comparable. Okay. So what we are saying, when you add a new object, every time what it will do, it will try to call the compare to method if it is a default sorting order. Okay, customized sorting order, we'll talk that. So for now, default sorting order. So every time when we are adding an object, then what we are saying internally, it is calling the compare to method, which is present in the comparable interface. Now I am adding an employee object. Employee object, it doesn't have any compare to method. So that is the reason it is showing that employee cannot cast to comparable interface. Now what we need to do? What is the reason that it is saying? Because it doesn't have compare to method. But that compare to method is present in comparable interface. So that means the string classes or the primitive classes, they are already implemented this compare to method. Now for our employee class also, if we can implement comparable, okay, it is asking to add the unimplemented method. I did that. So now what is the method it came? Compare to method. Okay. Now, so what? Let me go here. So what I was saying, every time when we are adding an object, it is calling the compare to method, and it is checking these three conditions, whether it is greater than, less than, or equals. Okay, now here say this. So I am always, I mean that this is the default override method. It is always returning 0. Okay, I did not tell that scenario here. So TreeSet, I mean that is uh, the 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 basic point about the TreeSet. It will not allow duplicate objects. Okay, so we have seen positive, we have seen negative, but we did not see any scenario about equals, right? So for example, if I try to add another 2, so so since it is 0, what is happening? For positive and negative, we have seen that if it is a positive, then the lower value will come before the higher value. If it is less than, the lower value will come. Sorry, if it is a lower value, sorry, if it is a negative, then the lower value. So basically, if it is a positive or negative, the lower value will come before the higher value. So based on that, it will check that. If it is equals, then what will happen? It will assume that that is already there. Say for example, up to here we got 2, 12, 23, 34, 93. So it will keep on check first 2 is 23, again 34, again 23, again 12. And when it comes to 2, since it is already there, now at this point it will not add this element. Okay. So we have seen this. So let me show you that again. Okay. So actually I am trying to add two times. Now in the result you will just see only 1, 2. Okay. We are just seeing only 1, 2. So what is happening internally? It is doing two things. One is it is comparing and it is placing according to the um, according to the value, whether it is positive or negative. If it is equals, that means that element is already there, so that it will not add that element. So that is how it is eliminating the duplicate elements. Okay, so it is eliminating the duplicate elements. So if the result is 0. Okay, now take this 1 second. So without implementing comparable, we have seen that class cast exception. And now what I did, I have um, I have implemented compareTo method, but I did not write any condition. It is just returning 0. So when it is returning 0, let me change some different values. Okay. Now if I print it, okay, how many values will print? What is the output? Now I have added 4 objects and I have implemented comparable interface and I have override that compareTo method, but just returning only 0. Okay. Now, if I print it, let me iterate it and print it. Okay. If I print it now, what is happening? It is just taking only the first object. But actually, what is happening? I have 4 objects. All are different. All are different, right? It is not even same. It is, I'm not adding the same object multiple times. Every time I'm creating a new object, and even the values also different. But still, what happened? It is just taking only one object, only the first object. So the reason for that is, internally JVM is not checking whether it is same object or different object, or whether it is having same all values or different values. It is not checking that. Blindly what it is doing, it is TreeSet, and we are adding some objects. So it will decide whether to keep that object, or if it is keeping, it has to go before that existing object, or it has to go after the existing object. It will decide based on the compareTo return value. Okay. If it is 0, then it will blindly follow that, okay, don't add that object because that object is already there. If it is a positive number, that number can be anything, 1, 2, or 10, or 100, or anything. If it is a positive number, then that means add that element, add that object after the existing object. If the result is negative, then it will blindly say that, okay, add that object before the existing object. Okay, based on those 3 result, positive, negative, or equals, it will decide what to do with that object, whether to add that object before the existing object, or add that object after the existing object, or don't add that object. So now in our case, since the result is 0 all the times, so first time we know that no comparison because it is just only one object, so it will add that first object, and from the second time onwards it will check with the existing objects. So when it is checking with the existing object, if your result is always 0, then that means it will assume that that object is already there, so it will not add that object. Okay, that is the reason we are seeing only first object. Now what I will do here, I will change the condition, say that let me say that here, I am saying student. Why again I am saying to student again? Okay, here I am just writing that condition to see. I mean, it's the same thing, whatever we discuss, whether it is less than or greater than. Let's see if it is coming or because at this time it doesn't have any value. Run it. Okay. So if I if I'm not implementing any logic, if I by default if it is always returning 0, what it is doing, it is assuming that that object is already there, so it is not adding that. Now what I did, I'm comparing based on the employee numbers. Okay. So the same thing, like in the earlier example, how it is comparing the numbers. Now I am comparing the employee IDs. So now what I did, I sort these employee objects based on the employee ID. So we can sort with any value like phone number or age or anything, name, anything. For example, if I want to sort it by age, okay. Now actually our current scenario is I just sorted based on the employee ID so that it is coming in that order 2, 12, 23, 25. Now if I sort it based on the age, so instead of ID, what I'll do, I'll say age. Okay, now see it was sorting based on the age 2, 11, 12, 34. So that means if it is a predefined class and if it is implementing comparable interface, then you can straight away add that class objects to the tree set. It will sort the objects. If we are writing our custom, our user defined class, and if you are adding the objects of our user defined class, then that class needs to implement comparable interface. That means we need to override compareTo method. The reason why we are overriding compareTo method, because internally every object that we are adding, so what it will compare to method on that object. If that object doesn't contain compareTo method, then it'll return an exception saying that class cast exception. So that is the reason we have added implemented compareTo method and override the. We have implemented comparable interface and override the compareTo method. So now we have seen it is not allowing duplicate objects, and the same case with the null. Okay, same case with the null. So it will not, of course you don't see any compile time error, but while runtime it will show that error class cast exception, or I think null pointer exception. Let's see that. So it is showing null pointer exception because what it is trying to do, it is trying to compare, right? So whatever the object that you are passing, it will compare with the existing object, right? So now we are passing null and you are trying to compare with some existing object. So since it is a null and you are trying to compare, so it is throwing the null pointer exception. So we cannot add null to a tree set. So TreeSet is not allowing duplicate objects, and it is not allowing null also. And the third point, when you are adding a user defined class object, then that class needs to implement a comparable interface. And the method, if the compareTo method is always returning 0, that means the TreeSet will take only one object. If you add multiple objects but still compareTo method is returning 0 all the time, so finally your TreeSet will have only one object. Okay, so that means overall comparable method, it's a default sorting order, or comparable interface is for default natural sorting order, which is having compareTo method, and for our class user defined classes we need that if we are adding that object to the tree set. Now the next thing is comparator. Okay, now the next thing is comparator. So the comparator is also having, it is having two methods. One is compare and another one is equals method. Okay, now let's see why we need it. What is the difference between these two? So far we have seen about comparable, because the tree set is expecting some comparison while adding object. So for that, since the comparable is the default natural sorting order, we have implemented that class with that interface with our class. So basically, but string, if you take string, we did not write anything, and but still okay. So apart from my session, every day you need to listen that noise, because every day they'll collect garbage at the same time. So that is the reason you're hearing the noise every day at the same time.
Okay, sir.
So I was saying, yeah, I forgot what I was saying. Okay. So comparator. So for string, we did not do anything, and but still, when you are adding string objects, what it is doing, it is sorting them based on the alphabet, if based on the alphabet, based on the alphabets. Okay, but we did not do anything. So that means for default natural sorting order, those classes implemented this comparable interface, and for our, so that is one thing, and for our customized, I mean our user defined classes also, we can implement comparable interface, and we can override the compareTo method that we have seen that. So basically we have override the compareTo method to sort the objects based on our condition. So one condition what I did, I was trying to sort based on the employee number, and in another way I am trying to sort based on the age. So with the comparable we can sort the objects based on our own logic. So that is also possible with the comparable interface. Now with the comparator. So comparator also, it is also doing the same whatever comparable is doing, but when we will use the comparator